Everybody, I am Mishra Demir. I want to talk about presentation, experimental and theoretical investigations of hysteresis behavior of damping bumpers at constant loading speeds. Damping bumpers, which are used as secondary suspension elements in air suspension valves, are widely used in commercial vehicles to minimize and control the effects of impacts encountered in road conditions. This study presents the experimental investigation results of cyclic compression at 1, 2, 3 millimeters second speeds of the hysteresis behavior of damping bumper prepared with two different filler materials, carbon black and multivolt carbon nanotube under static loading. We used rubber SMR 20. It becomes an elastomer with excellent mechanical properties, excellent tensile, elongation, tear resistance, and resilience, good abrasion resistance, and excellent low temperature flexibility. Without special additives, it has poor resistance to ozone, oxygen, sunlight, and heat. Poor resistance to solvents and petroleum products. Carbon black. The smaller the particle size, the larger the specific surface. It indicates oil absorption, the more complex configuration. Various functional groups can change the compound characteristic. A powder is vested from rubber industry and finds difficulty in its disposal. By using carbon black as filler in concrete, we can reduce this problem to a great extent. Carbon black is added to the rubber used in tire treads to high pressure hoses as other and demanding application. It was used so show soil, new tire, the highway, and rubber runway fields. Multivolute carbon nanotube, MWCNT. The chemical stability of CNTs is excellent. CNTs are diamagnetic and show a marked anisotropy sensitivity. These properties hold great potential for wide applications in fields as diverse as composites, energy storage, biotechnology, coatings and films, fibers, aerogels, and microelectronics. CNTs are difficult to handle due to their small size, so they are often used to create composite materials. Preparation damping bumper. The product can be used in a variety of fields and industries, including automotive applications and electrical components. They are the elements made of rubber, damping the vibration and impacts that occur in the mechanisms where it is mounted, preventing their transmission and at the same time reducing the noise. Protects a wide range of equipment against shock and vibration. Good permanent deformation resistance is especially important in terms of driving safety. In this method, for RC1, oil, carbon, black, and polymer bumper were mixed first. After the vulcanized were added, the mixing process continued. The materials were prepared in molds by passing through the spindle for a while. RC2, oil, carbon black, and polymer bumper were also mixed first. After the vulcanizates were added, the mixing process continued. Then the compound was melted in industrial solvent. and WCNT was added to solution. The solvent evaporated in oven. These composites are dried. Here, when the reactor results were examined, early curing started because scorch time was short in materials containing carbon black. The minimum torque value of the metals containing MWCNT was high. This affects this viscosity. The curing results of the material containing carbon black are considered to be more favorable. Measurements were made 5 times for each material and the averages were recorded. Hardness is related to the first-order failure ratio. The reason for this is that the hardness increased with the increase in the amount of filler per unit volume. But here is values are reduced or decrease. Maybe here the mixing is not homogeneous. In this study, samples containing 3 MWCNT and CV filler materials with a diameter of 25 mm and a height of 15 mm were prepared. They were cured at 160 Celsius for 10 minutes. The hysteresis behavior of the prepared compression samples was investigated under static load at 1 to 3 mm speeds. Static. Here, after the rubber metals with MWCNT filler material were prepared in the specified dimensions, they were tested in order to examine their hysteresis behavior. Tests were carried out at 5,000 cycles at different speeds under 50,000 Newton force. During loading under force, deformation occurred in the material after 1,000 cycles. For this reason, the cures were selected within the first 1,000 cycles. The cures were selected as 1, 3, 5, 700 and 900 cures and graphs were created. As the test speed increased, it was observed that the energy losses of the materials decreased. The reason for this is that the chains cannot return to their original state immediately between loading and unloading, resulting in movement restriction. Since the bumper materials to be used in air suspension elements must be long life, it's not considered appropriate for MWCNT filled materials to undergo premature deformation after 1,000 cycles. For this reason, the material does not have a long service life, which is inappropriate for use. Characterization testing. Due to the longer life of rubber metals containing carbon black, its use in bumper materials has been deemed appropriate. Bumper semi-finished products have been prepared in the specified dimensions of the bumpers used in our products. For the characterization test rubber, bumpers in the dimensions shown in the figure were obtained and it was observed how much they were compressed at the maximum force. Bumper materials were tested in 5,000 cycles and 50,000 Newton 1, 2, 3 millimeters second speed. The content of rubber metals is different from other materials. It's affected by many variables. Therefore, in nonlinear analysis, there is a certain deviation, approximately 7%, in the correlation between test results and analyzed results. You will see here finite element analysis at the 1 to 3 millimeter seconds. It can be noticed that with the increase of the test speed, the nonlinear behavior is more pronounced in the discharge phase. The maximum hysteresis loss value decreased as the test speed increased. The maximum stiffness was determined at a test speed of 3 millimeters/seconds. The general trend is for this stiffness to increase. When the experimental and theoretical measurements were examined, a deviation value of about 7% was observed. Analysis continues in finite element studies. Thank you for listening to me. Goodbye.